In this video, we're going to look at graphing radical functions. So we're going to start with a parent function of either a square root or a cube root. And then we will do our vertical stretch or compression, the reflection, which is the sign at the front, your starting point or your turning point, which is HK. This is also your horizontal shift and your vertical shift. And then we will come up with some properties to figure out our end behavior. Okay, so these first ones, we're just asking you to tell us what type of transformation occurs. So if we look at this, we can see that this is a square root function, and we have an adjustment to our x, and we have an adjustment to our y. So HK is going to be our shift. So remember, it's x minus your shift, and so this is going to be to the right 7. Don't forget it's backwards for the x. And then it is up 2 for the y. On the second one, we have a compression. So we're going to say vertical compression of 1/2. Okay, and then we have our shift inside. So then we have a shift to the left 2 and down 4. Okay. The next two questions are giving us a description of the transformation and asking us to write the function. So this tells us the square root parent function. So I'm going to go ahead and start with f of x equals. It's a square root function, so I know I'm going to need a square root. It tells me it shifted 7 units to the left, which is a -7. So x minus a negative ends up being a positive. And 1 unit down would be -1. And then it's reflected across the x-axis, so we got to put a negative out front to show that reflection. In the next one, it says a cubed root function. So again, I'm going to start with f of x equals. Now I'm looking for a cubed root, and they tell me it has a turning point at 2, -4. Well, remember, my turning point is my HK. So that tells me that my h is 2, so I would say x minus 2, and my k is a -4, so I put a -4 out here. There isn't a reflection and there's no compression or stretch, so that would be our equation. Here they're asking us to graph the function and then identify the key characteristics. So we reviewed this back early on when we talked about parent functions and their transformations. So if you need to go back and review those videos are still available to you. And I'm not going to ask you to draw a table and make this a perfect graph like we've done previously. I would suggest using Desmos in order to see what the general trend looks like. Your endpoint and your end behavior should definitely be on point with what we are trying to graph with each function. The individual points, though, as long as you're close, that's the important thing here. We're looking for trends. End behavior, increasing intervals, decreasing intervals. Your end point is important. The domain and range, having that accurate. Those are the things we're looking for here. Okay, so first thing I'm going to identify, this is a square root, so it's an end point. And my end point is going to be at HK. So this is going to be -1, -2. So -1, -2. So there's my graph, and it has a vertical stretch of 3, which means you're taking your graph. Remember, the parent function is going to look like this, something like this. Okay, and we're taking it and we're stretching it up. So that means it's going to go up faster than what it would normally go up, and then come over with the square root function. You can graph these in Desmos. I have this here. And this is about what the graph would look like. Okay. All right. My domain for this, notice my x starts at -1, which makes sense because I have an endpoint here. And so we're going to say that our x such that x is greater than or equal to -1. My range is going to start at -2 and go up. So that means that y is such that y is greater than or equal to -2. My end behavior, remember we have to go both directions. So as x approaches positive infinity, as it goes to the right, the y is also approaching, or the function is approaching infinity. Now, x does not approach negative infinity. It's going to approach -1 because that's where it stops. So we're going to plug in a -1 here. And as the function moves towards -1, it's approaching -2. Notice that this end behavior is going to match up with your end point. Increasing intervals. So we start at -1 and we go to positive infinity. And then if we look at our graph, we don't have any decreasing intervals. Okay, next graph. This is a cubed root function. And so these can go into the negative realm because we can have a cube root of a negative number. So the general trend for this one is kind of like this. Okay, so we're looking to shift this parent function. And again, this is going to be a turning point, not an end point. It's because there's no end to it. And so our turning point is going to be -3, 2. And so in the square root function, this is where it starts. In the cubed root function, this is where it changes direction. So this is where it goes from increasing to decreasing or vice versa. So we'll go to -3, 2, and we'll place our turning point here. This just gives me a reference that I know this area right here where it's normally 0, 0 is going to have to occur at this turning point. Okay, and we can go ahead and show you what that graph looks like real quick. Okay, and see my turning point is right here. All right. So our domain, the x's are the all real number set. The range is also all real numbers because it doesn't have a limit to it. Let's see, let's go ahead and put our graph up here. So this is going to go up in this direction, this, and then it's going to come down in this direction. Okay, as x approaches infinity, the function itself is also approaching infinity. As x approaches negative infinity, the function is approaching negative infinity. Our increasing intervals, so remember this is traveling left to right, it is always increasing. So we would say negative infinity to positive infinity, and we don't have any decreasing intervals. So this would be, we just put a dash there.